This video is to show two more examples of solving quadratics by factoring. Let's remember the four main steps that we reviewed in the previous video. So number one is to check to see if the expression or equation is ready to be factored. If not, we're going to need to rewrite it so that it's equal to 0. And remember, to be ready, it has to be in standard form. ax squared plus bx plus c equal to 0. There's the key part, equal to 0. So once we have it in standard form, then you'll be able to factor the ax squared plus bx plus c into two factors. Okay, and you can use the X puzzle and then the box to factor it out. Then we're going to apply the zero product rule and find the two solutions. And the zero product rule says if I have two factors multiplying and equaling to 0, then I can split those factors and set each one equal to 0 and solve each one individually. Once I have my two solutions, I'm going to check both solutions by substituting them into the original equation. So here's our first example. X squared minus 11x plus 28. So step one, check to see if it's equal to 0. In this case, it is. So we are good to go, and I actually can just skip step one. I don't have to rewrite it. It is ready to go. So then I'm going to factor. So remember, with factoring, we need to list out an A, B, and C. Oops. So our A value is 1, because there's an imaginary 1 in front of x squared. My B is negative 11, and my C is a positive 28. So then for the sum and product puzzle or X puzzle, A times C, 1 times 28 is a positive 28, and my B is negative 11. Then I'm going to find two numbers that multiply to be positive 28 but add up to 11, and I like making a list. 1 times 28 is 28, 2 times 14. 3 does not go into 28, but 4 does. 4 times 7 is 28. 5 does not go into 28. 6 does not go into 28. And then we're back up to 7, which we have. Now, all of these are positive. Positive 1 times positive 28 is positive 28. Positive 2, positive 14, positive 4, positive 7. But our B value is negative. So I have to then say negative 1 times negative 28 is positive 28. Negative 2 times negative 14 is a positive 28. And negative 4 times negative 7 is a positive 28. So they all still multiply to be a positive 28. And negative 4 and negative 7 will add up to a negative 11. So there are my two numbers I'm going to use to factor. So now I get to fill in the box. My first term is x squared. My last term was the positive 28. And I'm splitting up negative 11 into negative 4x and negative 7x. I apologize. When I wrote it up here, I wrote 11. And that actually was supposed to be negative 7. Again, negative 4 times negative 7 is a positive 28, and negative 4 and a negative 7 add up to negative 11. I apologize there. So my split is negative 4x and negative 7x. So now I'm ready for my GCFs. X squared and negative 4x, the first column, have a GCF of just 1x. The second column, negative 7x, and a positive 28 have a GCF of 7. My first row, x squared and negative 7x, have a GCF of just 1x. Negative 4x and positive 28 have a GCF of 4. But I know I have these signs that are negative. So I have to have negative somewhere. and this multiplies to be a positive. So the only way to make this work is to make both negative. Negative 4 times negative 7 is positive 28. X times negative 7 gives me that negative 7x, and x times negative 4 gives me the negative 4x. So I found my factors of x squared minus 11x plus 28 to be x minus 7 times x minus 4. And they are still all equal to 0. So step 2 is done. So now step 3 is to apply the zero product rule and find the two solutions. So I'm going to split this problem up and say the first factor, x minus 7, could be equal to 0, and or x minus 4 could be equal to 0, and I'm going to solve each one separately. So I'm going to add 7, and I get x is equal to 0 plus 7, which is 7, which is one solution. And for the second factor, I'm going to add 4, and that gets me x equals 4 as my second solution. So now I'm ready for step 4, which is just to check the solutions to make sure I did all of my work correct. Okay, so to do so, I'm going to scroll down here. I'm going to call this solution number 1, and I'm going to call this solution number 2, and I'm going to check solution number 1 first, which was x equals 7. Remember that I always need to go back and remember what the original equation was, which was x squared minus 11x plus 28 equal to 0. So to check it, I'm just going to, instead of having the x's in the equation, I'm going to substitute that solution. And then I'm going to follow PEMDAS to check that the left side reduces or simplifies down to 0. So PEMDAS, 7 squared, or 7 times 7 is 49. Negative 11 times 7 is negative 77, and I still have the 28. Then I'm going to just simplify. 49 minus 77 is negative 28. Negative 28 plus 28 is 0. So we get the right-hand side to simplify to be 0, and the left-hand side to simplify to be 0, and the right side was 0. 0 is equal to 0. Therefore, I know that first solution is correct. It works. So let's try solution number 2. So our second solution was x equals 4. So I'm going to plug it into the original equation everywhere there was an x. And then I'm going to simplify to see that it is 0. 4 squared is 16. Negative 11 times 4 is negative 44 plus 28. 16 minus 44 is negative 28. Negative 28 and positive 28 adds up to 0. So the left and right hand side are equal and true. So I know I did both of my answers correctly. So let's try one more example. We're going to go through it a little bit quicker. So our example here is 2x squared minus 7x equal to 5. Step 1, check, is it ready to be factored or is it equal to 0? That is a no, so we have to rewrite it. So to rewrite it, I'm going to move the 5x to the other side by using the opposite sign. And so to standard form, 2x squared minus 5x minus 7 equal to 0. So now we are ready to factor. Okay, so that is step 2. So I'm going to go A, B, and C. Our A value is 2. B value is a negative 5, and C is a negative 7. Then I'm going to think about my X puzzle. A times C, 2 times negative 7 is negative 14, and my V value is negative 5. And I'm going to think about my factors of negative 14. I can do 1 times 14, negative 1 times 14, or negative 2 times 7, or I can do the opposites. positive 1, positive 2 with a negative 14 and a negative 7. To get to negative 5, I need 2 and negative 7. Okay, so now I'm going to do my box. Okay, my first term was 2x squared, my last term is negative 7, and negative 5x is being split into a positive 2x and a negative 7x. My GCS of the first column, 2x squared and 2x, is 2x. Second column, negative 7x, negative 7, they are both negative, and they both can be divided by 7. My first row, 2x squared minus 7x, the only thing that pulls out is x. And then last row, 2x and negative 7, they're only both divisible by a positive 1. So 2x squared minus 5x minus 7 can be factored into 2x minus 7 times x plus 1. So now I am ready for step 3, which is the zero product rule, and then to split it and find both solutions. Okay, so I'm going to split the first one. 2x minus 7 is equal to 0, and x plus 1 is equal to 0. So for the left one, I'm going to make a zero pair by adding 7. So it leaves me with 2x is equal to positive 7, which I'm going to divide by 2. 7 divided by 2 does not reduce, so I'm going to leave it as 7 halves, or you can also leave it as 3.5. Then for the right solution, x plus 1 is equal to 0. This one's a little bit quicker. Subtract 1. And that gives me x is equal to negative 1. So my two solutions that I found were 7 halves and negative 1, and I'm ready to check my answer, or check the solutions. Okay, so solution number 1, which was x equals 7 halves. My original equation was 2x squared minus 7 equal to a positive 5x. Remember, you always want to use the original equation that was given to you. So I'm going to plug in my solution of 7 halves. Everywhere there's an x, so this time it's on both sides. And then I want to simplify both sides to make sure they are equal. When I square a fraction, I square both the top and the bottom. So 7 squared is 49, and 2 squared is 4. I'm just going to talk about the left side and keep going with it for now. When you multiply fractions, I just multiply the numerators together and the denominator of 1. So 2 times 49 is 98, and 1 times 4 is 4. Okay, 98 minus 7. Really, to do this, I need common denominators. So I'm going to just make that a 1 so I can see that I need to multiply by 4. 7 times 4 is 28, and 1 times 4 is 4. So 98 minus 28 is 70, and 70 divided by 4 is 17.5. So that was the left side. Now let's do the right side. 5 times 7 halves, 5 over 1. 7 times 5 is 35. 1 times 2 is 2. 35 divided by 2 is 17.5. So both the left side and the right side simplified to the same number of 17.5, which means x equals 7 halves makes this problem true. So now we're going to try solution number 2. Okay, so our second solution was x equals negative 1. So I'm going to plug it in for x, or substitute it in. PEMDAS, negative 1 squared is negative 1 times itself. Negative times negative is a positive, so negative 1 squared is a positive 1. Then 2 times 1 is 2. 2 minus 7 is negative 5 for the left-hand side. For the right-hand side, 5 times negative 1 is negative 5. So the left-hand side and the right-hand side are the same. So this tells me that the second solution, x of negative 1, is also a good solution. Okay. Hope this helped with your two extra examples, and you have a practice activity after this. Thanks. Bye.